Hi, welcome back to Gaming for Tokens. I'm Marshall, and in this episode, I'll be talking a little bit about laying the groundwork for scripting. If you've never done any programming or anything like that, that's totally okay. I'm approaching this from a very, very, very beginner level standpoint. So, if you have any experience with scripting, this is probably going to be a really boring video. But otherwise, I think it'll be really valuable for people who have a hard time getting through that initial barrier that is programming. I want to start by talking about the channel in kind of a weird segue there. The lengths of the videos have been about an hour long. I want to try to reduce that down to about a half hour. I don't know that that'll be the case with this video, but in future videos, maybe this one, they'll be capped at around a half hour or so. That'll help me actually make multiple videos, and instead of releasing them in kind of sporadic bursts, they'll be in a constant stream instead. Maybe I'll have a backlog of videos that I can edit at my leisure and release them in like a daily if possible. The first couple of videos being released daily is definitely a fluke. It's not going to stay that way if I keep up the 1 hour thing. So expect the videos to be a little shorter, a little bit more bite-sized, and a little more concise. I think they'll be better because of it. But anyway, so what I have here is my blank Unity, project scene. We're going to go ahead and we're going to start by creating a new script file. So there's a couple ways we can do that. The way that I usually prefer to do it is by right-clicking where I want the script to go and saying create a C# script. And I will be covering C#. I won't be covering JavaScript or Boo or Shader or any of that stuff. I will be covering C#, at least for now. I don't know enough about Shader or Boo to talk about it. I'd have to do a lot of research to be able to confidently present it. But JavaScript I do know a little bit about. It's been a long time, but I could probably go back into that if I got requests to do so. But C# works fine for what we'll be doing, and it works fine for most things that you'll be doing, I think. I'm pretty sure. So we're going to go ahead and create a new C# file. What we get is a new monobehavior file that is prompted to rename it. This part is really important. You don't want to click off of this, because if you click off of this without renaming it, then you're going to have a script called new monobehavior script that will also in the script file be set up to be called that. And I'll show you what I mean. If I click off of it, we can see what the script is over here. This is kind of a script preview, and we can see that it thinks that it is a new monobehavior script. If we then go and rename this to my script, for example, it doesn't change the actual code file. It changes the name of the code file, but not any of the code within. So if we were to compile this, so if we re-import this, it'll recompile, which is what the little wheel down here was. It should throw errors if we're compiling this, which I guess we're not right now, but it will throw errors because it won't be able to find the file associated with the class. So this is kind of a bad thing. This and this need to be the same. The way that you get around that is by the way you get to that, I guess, is by just creating it initially with the name that you want it to have. So now this is my script, and it is a public class my script monobehavior. So that's really important. Just name it something that makes sense when you create the file. Don't create it and then try to rename it, because you'll run into some issues sometimes. And you can resolve those issues, but it's just an extra step. It's just easier just to do it this way. So double click that file, and it should open up in whatever the default Unity script editor is. Mine is MonoDevelop, as you can see here. And I believe that's the Unity default now. It didn't used to be. It used to be Unisite. And Unisite's great. It's fine. I prefer MonoDevelop because while it's a heavier weight program and it has a lot more features than I probably use, it is really powerful, and it's a lot like Visual Studio, which is a program that is developed by Microsoft for scripting in C++ mostly for developing applications. So this is MonoDevelop. And so it opens up in a separate window, as you can see here. And I'm going to go ahead and maximize this, and I'm going to talk a little bit about the scripts. So the first couple things you should see is the packages that this script is using. We can ignore that for now, and we won't be adding any or subtracting any of these, so just ignore that, but these are packages. And then we should see a public class, whatever you named it, MyScript, monobehavior. I'm going to be making a lot of comparisons to things, so for those of you who do have some experience with programming, try to bear with me here. So a class is like the wrapper for your entire script, kind of. So the class is what this is. This is a MyScript file. It uses these things, but this is what it is. Within here are going to be a lot of stuff like functions. This is the things that this file can do. So this is a wrapper for a thing that it does. And this is another wrapper for a thing that it does. What we can do is we can just start in on this and make a couple lines up here outside of any of the functions. So within the wrapper, but not within the things that it does. And we can make some variables. There are a couple different things in code that define what objects are. And when I say object, I mean this is an object. A class is an object, for example. So if the object is named MyScript and it can do these things, we need to be able to describe it a little further. Think about it like you're describing a place. A place can have a name. It can have things within that place. Like if you say that's the carnival, the carnival has a specific name, I'm sure, and then the carnival has rides within that carnival. But the carnival also has other specific aspects of that carnival. So, for example, if this is a carnival, we have a int, which is a number, an integer number. So if you remember from your algebra classes or whatever, integer numbers are whole numbers. We'll go ahead and I'm going to finish this out and I'll explain it all. So we have an integer, which is our visitor count. I misspelled that. Visitor count. And it'll equal 10. So we have 10 people in our carnival. An integer number is a rounded number. So 10 is an integer, 11, 12, but not 12.25. That is what we would call a float value. Public float overall excitement equals 0.5. So this is an integer value and that is a float value. Those are your two types of numbers in any kind of programming language. I will say that a lot of people, myself included, define programming in a couple of ways that are really daunting. So, unreasonably daunting, I would say. So the people say that it's like learning a new language. If you can learn a language then you should be able to pick up programming pretty easy. I don't think that that's true. I'm really terrible at picking up languages, and I was pretty good about picking up programming. I will also some people also say that programming is the language of numbers. So if you're good at math, you'll be good at programming. I also don't think that that's necessarily true. I think being good at math will help you learn programming, and I think that if you are good at programming, it will teach you math. Because I also, in high school and things, I was terrible at math. But through programming, I actually found myself one day scribbling trigonometry on a notepad. I had never taken a trigonometry class in my life. I was teaching myself trigonometry through programming. Inadvertently. Like, I wasn't doing it as like an active thing. I needed to do something and it involved trigonometry, so I ended up doing it. That being said, though, I guess programming facilitates the need to learn it rather than the other way around. It's not, you don't need to know math to know programming. You can know math through programming, if that makes sense at all. Anyway, kind of a tangent, but going back to what these are. This is an integer and this is a float. So float values are non-rounded numbers, and integer values are rounded numbers, if that's easier to think about. Some other things here. So whenever we define a variable, which is what these are both different types of variables, we need a couple things. We need the level of protection on that object, which is a little more complicated than we need for now, but just know that if the thing you're making has public in front of it, then that means everywhere can access it, which for what we'll be doing is a good thing, but for later things it might be a bad thing. I'll explain it later, is the gist of it, but make sure you put public in front of whatever you're editing for now. It'll make things easier for the purposes of this tutorial. Then we need to have what it is. So we're saying, hey, there's this thing that everybody can look at and everybody can access. It is a number, it is an integer number, and it is called visitor count. So we know that that's the amount of visitors we have in our carnival, keeping the same example. And we have 12 people. That's the value of it. This is the default value. Keep in mind, we can, if we want, just define an integer value. What does if we do this, it will default to 0. It's the exact same thing as doing this. This value here is only the default value. We can change it afterwards. We can change it afterwards. The number here that we define is only here for reassurance purposes on our end. That's all it is. I mean, it'll change. Anyway, going to the next thing. So we have our public. We have a float, because this is a float value, which means that it's going to be, more often than not, it'll be a percentage or a finely tuned number. Those are usually the only two times you want to use a float. So if you want something that you can, well, if whatever you're doing is going to require the ability to put, like, well, if 0.5 is too much and you need 0.6 or 0.7, it's something that you're going to want to iterate on in that fine of a degree, if that makes sense at all. Or it's a percentage, because a lot of the time you can use this as a percentage. Like, for example, this is 50%. This would be 75%. And this would be 100%. So you can do things like that much easier with a float than you can an integer. For example, this same thing, if we wanted it to be a percentage as an integer, would look like this. It'll be a lot higher of a number, and we won't be able to get things like 0.52, well, 0.5552 or something like that. So, because effectively what that would be in this is 55.2, which we can't have as an int value, if that makes sense. It's not a rounded number. It'll automatically chop off that 0.2 as 55. And it's also worth noting that these two things right now are effectively the exact same thing if you treat them as percentages. So in other words, this would be out of 100, and this would be out of 1. But I usually will use floats, and most people, I believe, will also use float values instead of integer values for percentages. So that kind of talks a little bit about what the difference between a float and an integer is. We also have as a more basic variable, we have a boolean, which in C# is categorized as a bool, and this is a yes or a no, or a true or a false. So we have true and we have false. If I can spell today. This is a 0 or a 1. Think about it like a light switch. So I said here, park open. If we're going with the carnival thing, this is how many people we have in the park. This is the overall excitement in the park. Is the park open? Probably true. Yes, the park is probably open because there's people in it. Otherwise, that would be a problem because the park would be closed and there'd be people in it, which is not what we want. So that's a Boolean value. And again, you can switch any of these during the code. These values are not permanent. A couple others that we have are string. And strings are held within quotations like that. And they are like a name for something. So I don't know, fun time blast o Rama. Why not? So that's the name of our park. It's Fun Time Blast-O-Rama. And there's 12 people in it, and they're about half excited, and the park is open. So these are all different examples of different variables that we can use in our scripting to manipulate how the objects work and pass them between things. I don't know if I'll actually be able to get to a practical example of using these in Engine on this video, but that might be saved for the next video. I mostly just wanted to go over the different parts, and I hope you're following along. I hope this isn't too confusing, but these are basically I would say the 4 basic variables. That's probably accurate. I mean, there's more variables than this, but they're all very. Sometimes they're specific to Unity, or sometimes they're specific to other languages. But these are pretty much standard across all scripting languages. If they don't have one of these, then it's probably, I don't know, it's probably a really weird language. I've never seen a language that couldn't use these. With these, though, we can start talking about functions. This is a function. A function is a lot like a variable in the way that it's treated in scripting. It's kind of your own scripting, or your own variable, if you think about it this way. So like, these are the C# defined variables: int, float, bool, string. Start is a variable that you have, and it's something that you can tell things to happen in here. So if we wanted to change our park open to true, we can. So if we say park open equals false at the beginning, so it defaults to false when we start the game. When start is run, which is at the beginning of the game, I'll cover that in a minute, then our park becomes open, and we can say visitor count equals 1, and we can default this to 0 if we want. So what we're saying right now is we're saying that there's nobody in the park. There shouldn't be probably any excitement, and the park is not open, and the park name is Funtime Blast-O-Rama. Start says that the park is open, and our visitor count is 1. So somebody enters the park as soon as the park opens. There's a huge difference between, well, a function is something that, like I said, it's something that this object, my script, does. So you can create your own functions. It's pretty easy. You do it very similarly to the way that you do a variable. You say public, and for now we'll talk about voids only, just to simplify things. Public void, and we'll say that I'm not even sure, open gate. And then, so that's the name of our function. So we have a public void that is an open gate. For now, think about void like you're defining a function. Like up here, we would say an int, float, bool, or string. Here, we're saying void. Void means function for the purposes of what we're doing. And what we need is 2 parentheses, open and closed, an open bracket, and a closed bracket. Those are the things, that's the anatomy of a function for the most part. The parentheses, we'll get to why those exist in a little bit. Has to do with different functions communicating with each other, and the 2 open and closed brackets define the beginning and the end of the function. In a sentence, for example, you would use a period. Think about the closed brackets as the period, and think about the open brackets as the capital letter of your sentence. So we're starting a sentence, now we're ending a sentence. What the body of that sentence is, or what the things that happen during that function are, you can define. So you can say, I'm not sure. Well, we can put park open here, because if we're opening the gate, obviously the park is open. So we can say the park's open here instead. And then we can Yeah, so that's a function that we made that does something. It sets park open to true. From here, what we can do is call that function using another function. Might seem kind of convoluted at the beginning, but I'll explain why it isn't in a second. So we can say open gate, and we'll see that it auto-completes for us there. Now, open gate is called as soon as the game starts, because start runs when the game starts. And that's going to set our park open to true, and then we're going to get a visitor because our park is open. What we can also say in here is the overall excitement equals 0.1. So we have a little bit of excitement because the park is opening, and we get a person. We can even put this in here if we want. We can put anything in here that we desire. The whole point of doing separate functions like this is, and I'm just moving it below start for organization purposes. The whole reason why we would do something like this is if we wanted to ever call open gate again, because say if we wanted to call it down here on update, which I'll explain what update does in a minute, then we can. And it does the exact same thing here. Here, as it does down here, it's going to set park open to true and the overall excitement to 1 and visitor count at 1. It'll do it once and then it'll do it again. Another good analogy, I guess, for functions is it's a little machine that does something. So if you have, I don't know, a machine that opens the gate, for example, you would want that machine to do that same thing over and over and over again, but you wouldn't want to necessarily... It's the difference between going over and pulling the gate open or going over and hitting a button that opens the gate. We've just created a button that opens the gate with this function, if that makes any sense at all. And that's basically functions in a nutshell. There's a lot more to them than that, but that's how they work. The parentheses here, and we can make a new function here, public void, and we're going to call this one set overall excitement. So in here, what we're going to do is we're going to take this overall excitement thing, and we're going to set it. We're going to, when this happens up here, instead we're going to tell it to be a certain variable, a certain value, rather. So we need to be able to tell this function what value we want to set that to, because we're going to say overall excitement equals something. But what is something? That's what these little parentheses are for. So we define a variable inside of them. We say float new excitement, and now whenever we call this function, we have to pass in a float. For an example, I will say set overall excitement, open close, but then I have to feed in a number, so I'm going to say 0.1f. This right here and this right here do almost the same thing right now. One thing I have to do is put that down here. So what we're doing is we're telling set overall excitement to happen, so it does this, and then we're feeding it in a 0.1, which goes here. And now we can use that variable in here, in the set overall excitement function, to do something with. So now we don't need this any longer. And we can call overall excitement wherever we want. We can say set overall excitement down here to 0.25 f, and that does the exact same thing. A couple things that I do want to say that I kind of ran right over and didn't even talk about, which is really, really bad for me, is what this little f means. The f means float, and this is a I've never had to do this in any of the game engines that I've used so far, but f means float. If we just do this, then can think that what we're trying to do is define an integer value to a float value, which is not okay. Because see how it's kind of like if we did this number right here, this 1, is a integer value because it's a rounded number, but we're assigning it to a float value, and then the compiler, the thing that figures out if your code makes sense, gets confused and says, whoa, what are you doing? This isn't a float. This is a float value, not an integer value. So you have to define that with f, and f tells it that it is a float value instead of an int value. The other thing that I kind of glossed over are these semicolons. A semicolon is the end of a line. So at the end of every single line that you have, if it doesn't have an open bracket, it needs to have a semicolon. If it doesn't have a semicolon, then you'll start to see these red lines, and these red lines mean that there's an error. If you hover, just like in every word editing program, like Microsoft Word, if you hover over this, it should tell you what the error is, and in this case it's saying, I don't understand what visitor count is. Because the way that it is seeing this line, because there's no semicolon, is like this. It doesn't understand why the line hasn't ended yet, but if we do this, suddenly this makes sense to the compiler. It figures out that, oh, okay, you're ending this line and you're going to the next. That's really, really important, and a lot of the time, when I was starting off, there was a lot of I forgot a semicolon and my code was broken and I couldn't figure out why it was broken. So be warned that that's a thing that you need. You also need these open close brackets. Without them, again, stuff will break and it will throw errors. Like this right here, it doesn't understand why you're defining a function inside of another function because this function hasn't ended. So make sure you start and end everything. Usually whenever I'm making a function, I will do this. Public void new func. I start and end it immediately so that I don't forget to later. And just keep that in mind whenever you're doing stuff like this, because it could be really, really bad if you don't. So I've kind of talked about functions a little bit and how to pass things into them. I've also talked about the different variable types and how to set them. That's what these are down here. These are considered setter lines. And so the next thing I want to talk about is how to get things from a function, because not all machines just do things for you. Some of them give you stuff. So if you've ever seen like a 3D printer, a 3D printer will, you give it something and it will spit something back out. And that's essentially what we're going to do with this. We're going to say public float, just like we would up here. We would say, hey, I want this to be a float value. That's what we're doing. And we're going to say get overall excitement. And we're going to close that off, just like we have up here. So instead of passing in something, we're just going to send something out. And the way that we send something out is with the return call. And we tell it what to return. So what this is saying is, I am defining a public thing, so something everyone can look at. Everything in the code file and every other code file and everything in the game can look at is going to be a float value that I'm getting back, and it's called get overall excitement. The thing that we want to return from this is an overall excitement value. This is the way to get stuff from other functions. You usually don't want to do it, well, I mean, a lot of the time with these public variables, you can do it in another way. But typically speaking, you want to get in the habit of using what are called getters and setters. This one down here is a getter, and this one up here is a setter, because it sets a variable and this one gets a variable. That's their unofficial name, basically. And I would like to say, the next thing I want to talk about is commenting. Commenting is really, 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 really neat. It's really, really, really powerful in kind of a weird way. because it's not powerful to help you make the code, but it's powerful to help you understand what you've written and what other people are writing for you or whatever you're doing. This line right here is a comment. You start a comment by tapping // and after that you can type anything you want and it's not considered code. The compiler will ignore it. So if we wanted to write a tip here for what this does, this sets the variable overall excitement. And down here we can say gets the value of overall excitement. So this seems a little bit strange at first because, I mean, you can usually tell set overall excitement, that sets the overall excitement, right? But a lot of the time you'll have a function that, like, it does a lot of stuff. It does an absurd amount of things. And if someone else is going to look at that code, they could spend like an hour trying to figure out what this function does that's, 300 lines long. Or you could just put a little tip at the top that says, hey, this does this. And they could go, oh, that makes a lot of sense now. Instead of having to read the whole thing and try to understand everywhere that you're going with it and everything you're doing, they can just see that and go, great, I understand what they're trying to do here. Functions are really, really valuable, especially if you've been working on a project for a few months. Some of the code you write at the beginning, some of the code you write at the end. And when you're at the end and you need to go back and look at the stuff from a month ago, maybe you don't remember what some of the stuff does. You just know that it works or that you need to expand upon it or whatever. Comments will help you a lot in remembering what you've done. It's kind of weird saying that, but it's true. It's so easy to forget what you've done. There's a couple other things in programming that are undoubtedly useful, and and they're kind of like questions. So I think they're called conditionals. I think that's the name of them. But either way, I'm going to define one here in the update function, and I'm going to call it if. And an if statement is really interesting. It makes a lot of sense. So what we can say here is if park open equals true. So what we're saying here is if the park is open, then do this. So if the park is open, overall excitement equals overall excitement plus 0.1. So what this means is if the park is open, increase the overall excitement. Or oops, this is supposed to be overall excitement. There we go. Not set overall excitement. That is wrong. All right, so if the park is open, then we want to set overall excitement to overall excitement plus 0.1. This is going to increase the overall excitement 10% every frame of the game, because update is called once per frame, as this little comment here so handily describes. That's really, really fast, and this is probably really, really, like, none of this code makes any sense, but it's all good examples of what we'd be doing with this. So, if the park isn't open, how do we say that? Well, we could say if park open equals false. We could do that, or what we could do, but then that removes the ability to do this, or what we could do is put another if, and just copy this whole thing down and put it here and say if this equals false, then do this minus 0.1, so that means excitement's going to go down. But instead of defining the second if statement, which there's no sense in, you can usually just use an else. So if the park is open, then increase the excitement, or otherwise decrease the excitement. So what this is saying is, after the park is closed, then everybody will be less excited than when it's open. That makes sense. A couple things to do with if statements. You may have noticed this double equals. Up here we use a single equals, and the single equals is defining something as this. park now equals true. This statement right here, this is essentially asking if park is true. So this park open equals true will return a boolean. It will be true or false. Just like we have this thing down here that returns a float value. Park open equals true will either say yes it's true or no it's not true. And if it's not true, then it'll go down here. And if it is true, then it'll go here. It's kind of a weird way to describe that, but I'm trying to think of a better way to do it. This is a question, and this is a statement. That's the best way I can say it, I think. This means that is that, and this asks if it is that, if that helps at all. And then the else statement is talking about if none of the conditionals have been met. Likewise, we can also do a else if, which is the same thing as an else statement. It's kind of like if you took if and else and mashed them together. So this will say that else if visitor count does not equal 0, then do this instead. So now what we're saying is if the park is open, then overall excitement plus equals 1. But if the visitor count, well, yeah. So if the visitor count does not equal 0, so think about this as not, this as equals, I'm pigeonholing myself here, I think, in my descriptions. So there's a bunch of different types of descriptors for else, for if statements. There's equals equals, there's not equals, there's greater than, less than, greater than equals, less than equals. I think that's most of them. So this one right here means, is this the same as that? So is park open true? This is this not that? So is visitor count not 0? Do we have not 0 people in the park? Because if we had 0 people in the park, then we would want to decrease the excitement because nobody's in the park. But if there's people in the park, then we want to do something else instead. Is this greater than? So likewise, instead of not equals 0, we could say greater than 0. That's kind of a just a double check to make sure that visitor count wouldn't equal -1. Because if it was less than 0, then that would be bad. Hence, less than 0. So the other things that we can do is if it's less than or equal to 0 or greater than or equal to 0. This is kind of where it gets confusing because the equals equals is a compare and this is a set, yet the single equals here is a compare as well because it's coupled with another symbol. So 2 symbols usually means a compare in the exception of greater than or equal. And the greater than, if you read it like I said, it makes sense, like greater than or equal to 0. So visitor count is greater than or equal to 0, do this instead. And if we're less than or equal to 0, which is what we want to do here, I think, sensically, we want to say that visitor count equals visitor count minus 1. So if this is kind of the context that we're framing. If the park is open, then we want to increase the excitement. If it is not open, then we're going to do the rest of this stuff. We're going to say if there's people in the park, so if it's if it's greater than 0, if there's people in the park, then we want to decrease the amount of people. And if there's no people in the park, because that's what the else is, so we're going to go if this, otherwise do this. But if this condition isn't met, like if visitor count does equal 0, then we're going to do the last statement, the else statement, which is overall excitement equals overall excitement minus 1. So we're going to, if the park is open, then increase the excitement. If it's not open and there's people in the park, decrease the people. But if there's no people in the park and the park is closed, then we're going to decrease the excitement. So I hope that makes some sort of sense. I know if statements can be kind of confusing at first, but basically you're saying, hey, is this true? Or, well, not in the programming sense, hey, is this true? But is this correct? And if it is correct, do this. So we're saying, is park open equal to true? If that's the case, then do this. If visitor count is greater than 0, then do this. If overall excitement is, if not, then do this instead. So we kind of have a 3-step if statement here, and these are all connected. So likewise, if we did this, then if the park open was true, the excitement would increase, and then it would also do this if visitor count was greater than 0. But because we did an else instead here, it'll only do one of these 3 things. If all of these were if statements, it could potentially do all 3. And the reasoning for that is each if statement is handled separately, but if we put an else in front of these, then that links them together. So if we do this, then all 3 of these are potentially connected, and they are within realm of referencing each other. So yeah, if this one isn't true, then it'll go to the next one. Likewise, if we decide to do something really weird in here, like after this else if, put another if in, it will throw a bunch of errors and be really confused and not understand why there's, well, in this particular case it won't, because this if and this else are now linked, and this if and this else if are now linked. But if we were to define a variable in here, like a Boolean error Boolean, because that's what it's going to make, then else all of a sudden is freaking out because it's not linked to anything else. It's not linked to an if statement, and it needs to be, because it's basically saying if do this, then if do this, right? Like if this is true, then do this. Otherwise do that. So this is saying just otherwise do this, and it's saying, but I don't have a condition to not do this, so I'm confused. Hopefully that isn't confusing. I don't know. If statements are weird and they're hard to describe, but they make a lot of common sense if you can wrap your head around it. Yeah, we'll be using them a lot, because that's one of the foundational pillars of programming, is seeing if things are certain things and then doing things because of that. So next I wanted to talk about a couple other things, like loops. Now that we've talked about what ifs and elses are, loops are the next big thing. There's a couple different kinds. There's a while and a for. Fors are a lot more complicated. They're, but I mean, the easiest way to think about a loop is that I mean, if you think about a loop, it's if you're stuck in a rut, for example, it's a common phrase, then you're doing the same thing over and over and over again, and that's what a loop is. A loop is stuck in a rut, so it will check a variable, and it will if that variable is true, so we're going to say while park open equals true. So while our park is open, we're going to do this thing. We're going to say visitor count equals visitor count plus 1. What this is going to say, and this is actually a really, really bad while loop. While loops are really, really dangerous. They're simpler, but they're dangerous. The reason why they're dangerous is update is called every frame, right? We've talked about that briefly. So on the first frame of the game, this is going to call this, and park is definitely going to be open, because on start we're opening the gate, which opens the park, right? And it's going to keep increasing visitor count forever, because park open never unhappens. It's never set to false. So this will on the first frame, this chunk of code will never end, and it will it's what people call an infinite loop, and it will break your game. It will actually crash it completely, and if you run this in Unity, it'll crash Unity. So what we need to do instead is use our handy little if statement, and we need to say if visitor count is greater than or equal to our a new variable that we're going to create up here called visitor capacity. And we're going to say we can only have 100 people in the park. That's the maximum amount of people we can have. So if we have more people than this, we will say park open is now closed. Park open is now false. So what we're saying here is while the park's open, visitor count equals visitor count plus 1. So we're going to increase visitors until we no longer can, and then we're going to shut the park down because we can't have people in here anymore. So we're going to close the gates, and we're going to... and actually, a better way to do this would be to have a new function called closeGate, which sets park open to false, and maybe does some other things. Like, I don't know. We can put other things in there. So if we wanted to, we could add more stuff. So instead of doing this, we can just call close gate. So we have an open gate and a close gate now. And that sets park open to false. So now this while loop will stop happening. That's kind of what a while loop does. It does something until it can't anymore. And this is what we define as can't anymore. A lot of the times we'll use this as a... so likewise, if we wanted this to terminate in a different way, we could say while visitor count is less than or equal to, or well, less than visitor capacity. So we can say that this loop is going to happen until we reach our capacity. This one right here is a much simpler version of what I just had. The only difference is this one doesn't close the gate automatically. So what we'd have to do after this is close gate. So this is going to run this loop until visitor count is greater than or equal to visitor capacity. And when it is greater than or equal to it, it's instead just going to keep going with the code. So loops are really interesting in the way that they, like, code runs from top down, right? It's like you would read something, so it does this line and then this line and then this line. But once it hits a loop, it does the loop until it's finished and then moves on to the next line. And a while loop is dangerous because of that. If the while loop never finishes, it will break your game because it won't move on to more code. It'll just stay on that one frame forever. If that makes sense. I hope that makes sense. So the other one we have, the more complicated one that we have, is a for loop. For loops come in 3 parts. There's a part 1, a part 2, and a part 3. Unlike the while loop that just had a condition for when it ends, this for loop will define its own conditions and its own things that it does. So the first thing that it does is a variable. That's the first thing. And usually what people do in this is they say it's an integer. They usually say int I equals 0. What this means, just like up here we had an integer of visitor count equals to 0. This is essentially doing the exact same thing. It's just defining it within the constraints of a for loop. So we say, when we define this for loop, we also define this variable I. The next thing we have is a condition, if I can spell. And that's going to be here. So if we say I less than visitor capacity. So much like our while loop, we can define when we want the loop to end. Well, rather, in this, we're in both instances, we're telling it when to not be done, and then once these aspects are not met is when it's finished. And then part 3 is what we want to do every time the loop happens. And this is kind of going to be my foyer into shorthand, is I++. So in the past, what we've been doing is we've been saying things like visitor count equals visitor count plus 1. This is the exact same thing as saying visitor count plus plus. The plus plus is programming shorthand for plus 1. It equals itself plus 1. If you just said visitor count plus 1, that doesn't do anything because you need the visitor count equals in front of it for it to be a proper declaration. So most people end up using a plus plus. You can use either of these, whatever makes sense to you, but the plus plus is a much simpler and faster way of doing things. Most people, I think, would agree with that. So what this is called is an iterator. What that means is we define a variable, we define a condition for this loop, and then we define an iterator for the loop as well. This for loop will not go on forever. It's impossible for it to go on forever because visitor capacity is defined up here to be 100, and I is defined as 0, which means that I will run 100 times. The first time it'll run, I will be 0. The second time it'll be 1. The next time it'll be 2, then 3, then 4, then 5, all the way to 100, and then this loop will stop. So this loop will run 100 times. If we wanted to see this, well, I'll go over debug statements last. Debug statements are really, really useful, but I don't know, not yet. For loops are usually what I'm going to be using, just because they're less dangerous, they're less for me to screw up on, and like while loops, the easy way to do this, the way that you would duplicate this is you would say, and these are going to be the exact same loop done with fors and whiles. So this will be an example of int I equals 0 while I is less than visitor capacity I++. And I believe it's freaking out because I has already been defined. Yeah, so I has already been defined up here, and you can't have variables with the same names. For example, if I was to take visitor count and just copy and paste it, it would yell at me because it says visitor count already exists. Kind of like, well, really a lot of computer files and things like that. You can't have files with the same name of the same type, and that's basically what we're doing here. I think if we want, nope. So we can't even have variables of differing types with the same name. It's not okay. It says my script already contains a definition for this name. Stop it. So stop it. But that's why it's giving us an error down here if you saw that, because I already exists up here in this, so we can't have it down here as well. But for example purposes, this is fine. This while loop right here with this variable is the exact same thing as this, but this is in 3 lines and this is in I believe 4 lines. Yep. These are the exact same thing. The difference is this has a potential to break your game. This doesn't. While loops are valuable. They do have their place, and they I've had to use them on a couple of occasions, but I would say 95% of the time you can use a for loop, and you definitely should, because there's no reason not to. Hopefully this makes sense. That's really all I have to say about loops, I think. But for loops are what you're going to want to use, and while loops are less complicated, but as a result, a lot more unstable, and they will break your game probably. And that's loops. So the next thing I wanted to talk about, well, we'll keep our for loop here. The last thing I wanted to talk about was how to do debug stuff in Unity. And I'm going to clear a lot of this out, so sorry for that, but I'm actually going to run this. And I don't want it to explode on me. So I'm just going to remove... Well, I'll keep all this stuff here. So what we're going to do is we're going to say... well, just look at what I'm doing and try to keep up. Oop. Debug is the Unity debug class. It's basically, or object, I guess. It is the thing for doing debug stuff in Unity, like printing out messages to the console, or sometimes drawing lines in the editor and drawing objects and shapes and things like that if you ever need to. This is really, really useful for getting information about your code and about things that are happening as they are happening during your game. So in other words, if I wanted to say debug.log, like I had, that is going to print something out to the editor. And I think if we hover over this... Nope. Alrighty. I think we have an error somewhere. It says we do. I don't think we do. That's weird. Anyway, debug.log will... it'll print out anything that we put in here. So in other words, if we put visitor count in here and we make visitor count equal to I, so in our for loop, I is going up 1 every loop, if you remember correctly. So it starts off on 0, then goes to 1, then 2, then 3 every time this loop is run, and it's going to go to 100. We're going to set visitor count to that number, and we're going to print out visitor count. So what we're going to see here, I'm going to go back to Unity really quick. So I'm going to minimize this. I have my script here, create an empty game object, and I'm going to drag and drop my script onto the object. You'll notice that a lot of our variables that we had created in here in MonoDevelop, visitor count, visitor capacity, overall excitement, park open, park name, all show up over here as things we can edit. So if I wanted to change visitor capacity to 25, I just did that. Oops. I just did that. And I can also change our name from Funtime Blastorama to something else. I can check this box for if we want park open to be true or not. How much overall excitement do we want in our park? That kind of thing. We can do all that from here now. We can also set visitor count to 10. So we already have 10 people in our park. But when we run the game, because again, this is an update is called once per frame, what we're going to see is nothing initially, but if we go to our console, we'll see that it printed out a bunch of numbers. It printed off 0, 1, all the way to 24 because of this loop. Now, you might be saying, but wait a second, it only went to 24 and our visitor capacity is 25. Well, yes, because it also included 0. So, I'm going to pause it because it's printing these a lot. So, because we included 0, we have 25, because 1, 2, 3, 4, all the way to 24, plus 1 for 0, if that makes sense at all. Programming is, because we start off at 0. If we want to start this off at 1, and we wanted to go to less than or equal to visitor capacity, it would go 1 to 25, for example. A lot of programming starts off on 0, so you have to get used to that. Instead of counting 1 through whatever, like you have been for your entire life, you have to count 0 through whatever. So you're always going to end up with 1 more than you think you do sometimes. Initially. You'll get used to it, though. There's a reason for that, and I'll cover that in a later, in the next video when I talk about arrays and the more complicated variables, and how to edit them in, well, how to make functions that return things and do stuff for you. I'll come up with a little project. I don't know what that's going to be yet, but we'll make a function that actually does something. It'll be exciting. But for now, that's kind of an example of how to debug something. So the way that we can use this is we can say, because we can feed strings in this just by typing in quotes, right? Just like we did up here for the park name. We can say print something And then when we run our game, that's all it's going to say. Instead of the numbers that we had in there before, it's going to say print something. If you see here, it'll say print something. And this number over here is how many times it's saying it. So it's doing this every frame. So if we pause our game, we know that this has been done 4,625 times because it's happening every frame. So update can be dangerous as well if you're doing stuff in code. But for now, it works good for the purposes for which we are doing this. So what we can do here is we can say park name, and then we can add to this by saying plus stats. So these are going to be the statistics of our park called Funtime Blastorama, and we're going to say debug.log, and we're going to say visitor count. Visitor count colon space, and we're going to add the visitor count variable after that, and then we're going to keep going here, and we're going to say out of basically visitor capacity. Now because we're increasing visitor count to that capacity, what we're going to see here instead now is Funtime Blastorama stats, and then I'm gonna turn off collapsing on this, because that's what's the collapse button here in the console will stack messages that are the same. So in other words, we have our Funtime Blastorama passed 150 times. But if we unstack that, what we get here is Funtime Blastorama stats, visitor count 0 out of 25, 1 out of 25, 2 out of 25, so on and so on. So what we're going to do to make this a little easier to see is we're going to add a couple spaces before visitor count. I'm going to copy that, and I'm going to go debug.log overall satisfaction, and I'm going to print after this the overall excitement. So what we can do with this instead here is we can go overall excitement equals visitor count, or visitor capacity divided by visitor count. Actually, no, the other way around. Sorry. Visitor count divided by visitor capacity. So what this is going to say is the overall excitement is essentially a percentage of the amount of people in the park. So what we have here, we're going to clear this and we're going to play it. And we're going to pause this. And we're going to say that at the beginning here, the overall satisfaction is 0 because there's no one in the park. It's still 0. It's still 0. Until we get down to, oh, didn't work. So, visitor count divided by excitement equals that. So, I may have to do some nope, that didn't work either. I think I have that backwards. Visitor capacity hang on just a second. Nope, okay, yep, that was right. I'm just doing something wrong. But either way, so what we have here is we have a debug of our stats for the game, for our park, Funtime Blastorama. So we have Funtime Blastorama stats, the amount of people we have in the park, and the amount of satisfaction they have. We can keep going with this if we wanted to. We could say we only want to do this if the park is open. That's the only time we want to do this whole for loop and print. So as soon as the park is closed, we'll no longer do that. we can also we can print a bunch of other stuff. We can do more things in here, but that's basically how you debug log stuff. And I encourage you to check out some of the other stuff in here. Now, the way MonoDevelop works is once you type something that is a thing and you do a dot after it, you'll see all the different functions and things within that object. So in debug, we can do a debug break, we can do a draw line, a draw array, a log, like you saw, so we can just do log, and it'll tell us about that thing. It'll say over here on the right what we send to it. We can send it a couple different things, and by using the left and right arrows, we can go between these one at a two, and we can see what we can do with these things. So we can log an error, we can log an exception, we can log a warning. Log warning is interesting. It's just a yellow debug log, basically. Warning. So when we come back in here and we print, we should see yellow lines being printed, called warning. So this is really useful for if you have a lot of debug in your code. You can make something pop out and then change it back. So we can say, okay, well, that's fine, but we don't want this to be a warning anymore. We just want it to be a log. Perfect. We can move on, and that way you can have something kind of pop out in your console. If you really, really wanted to pay attention to something for a little while, you could. And then debug.log error is going to be the same thing, except it'll be red and it'll be an error. So if we do this, it says error, and there's a bunch of them. But because we have error pause checked, it paused our game as well. We can see that up here. And that's something to note. So you don't ever want to use log error unless you really want the game to like pause and you have error pause checked, or it's like a weird case that you don't want to happen. So example, if visitor count is less than 0, so if we have negative visitors in our park, this is actually an extremely good example. We want to do something like this: visitor count I don't know. So what this is going to say is that if at any point in time we have a negative number of visitors in our park, which is a bad thing because we should never have negative people. We should always have either positive or 0. If we have a negative number of people in our park, if the number of people in our park is less than 0, we want to log an error saying, whoa, this is bad. This is sub-0. We can't have that. That should pause the game and give us some valuable feedback into something is broken. We did something that wasn't right. And this is an easy way. You can set up checks for this in your code. You can set up checks for yourself in your code like this. So on the next video, I will be talking about going into a little bit about arrays, which, by the way, look like this. They're defined by these little brackets here, and I will talk about how to use those and how to get into those. I'll also be talking about how to make private variables, which is basically the exact same variable minus the public in front of it, so like that, and why you'd want to use one or the other. And I will hopefully have come up with a little code project for us to do in that video. But for now, I think that's going to be about it. Make sure you look at the scripting reference. Again, that's going to be located up here in help scripting reference. If you have any questions, and explore, go nuts, and I think that's it. Thanks for watching, and bye-bye.